All right, so here's basically the information that was provided in this problem. You were told that the radius of the large circle was 4, the radius of the small circle 2, and you were told that this distance from center to center is 10. And from this set of information, it asks you to find the common internal and common external tangents. Okay, so let's start with the external tangent, the red line. Okay, when we're working through this problem, what we're going to do is we create the radius to that point of tangency for each of the intersections of that common external tangent. Okay, and again, the key is that tangents intersect radii at a right angle. Okay, once we set up that right angle, what we can then do, label the pieces. We know that the radius is 2 and 4 for the larger one. Okay, and then we're going to cut off a rectangle from the smaller circle. So if we go to the center of the smaller circle and we square off a rectangle from there. Okay, so we knowingly, again, that the line that we add in, we're going to make it a right angle. So it didn't exist before, but we're going to make it a right angle here. And the reason for that is we want this to be a rectangle. Okay, so opposite sides in a rectangle are equal. So we know that this portion is 2. We know that these two sides are equal. So if we call this x and this x, all we need to do is solve for x and we have our solution. So since adjacent angles of linear pair, if one's right angle, the other one will also be a right angle. We're dealing with a right triangle here with one side of x, a hypotenuse of 10, and the other leg, since this whole length was 4 and this upper portion was 2, what's left for this lower portion? Also 2. So in order to find x, we're going to use Pythagorean Theorem here in this right triangle. Okay, and so let me just highlight real quick. So here's the triangle that I'm dealing with. Okay, and so the Pythagorean theorem for that is 2 squared plus x squared. The sum of the squares of the legs is equal to the square of the hypotenuse. And so if you simplify your expression, subtract a 4 from both sides, extract the square root. And if you take the square root of 96, you can look to see are there any perfect square factors you can remove, or you can use your calculators and just compute the square root, which will simplify it for you. But you wind up getting 4 root 6 as your answer. So this external tangent is 4 root 6. Any questions on that part of the problem? All right, the second part to this problem is to solve for the common internal tangent. Okay. So if we look at the other pieces of information, so let me turn some of these into kind of lighter colors. So all I did is I just lightened that a little bit so we can focus on the other pieces. All right, in looking at the common internal tangent, right, again what we're going to do is we are going to draw in the radius to the point of tangency for both circles. Once again, that radius and that tangent are going to intersect at right angles. And then once again, we can label our radii. We have a radius of 2, and again, this one is a whole length of 4. Now, we still know that this length right here is a distance of 10 combined. And so we can break this down. We know we have right angles on these two triangles. We have a pair of vertical angles. So by AA similarity, we're dealing with similar triangles. And similar triangles are proportional. All their corresponding sides will be proportional. And so what is the ratio between these two triangles? Corresponding piece of 2 and 4 tells you the ratio is 1 to 2. Okay, so the ratio of parts is going to be 1 to 2. So we have two choices for finding this, the kind of the breakdown of these lengths for the green segment connecting the centers. Okay, and one choice is to let one of the lengths be expressed as x. The other length would be the whole minus the other part, so 10 minus x. And you could solve this by setting up proportions. So this is maintaining the part-to-part relationship. So by part-to-part, we know that x over the corresponding part, 10 minus x, is equal to, is it going to be 1 to 2 or 2 to 1? The x is from the smaller triangle or the larger triangle? It's part of the smaller one, so it's a 1 to 2. And we can just solve this mathematically. So if we cross multiply, 2 times x is equal to 1 times 10 minus x. Add x to both sides. Divide by 3. So we get this portion to be 10 thirds. And then this portion is, you can either think of it as being double that, so it's going to be 20 thirds. Or you can think of it as being 10 minus 10 thirds, which will also be 20 thirds. It doesn't matter, either way is fine. But once we get to this step, in order to find this piece, the last leg of the small right triangle formed there, we need to use Pythagorean Theorem again. So I'm going to call this portion y. And so if I take 2 squared plus y squared, that's the sum of the squares of the two legs, has to equal the square of the hypotenuse, 10 thirds squared. Okay. I can go ahead and solve this. So 4 plus y squared is equal to 100 over 9. If I subtract 4 from both sides, subtracting 4 is equivalent to subtracting how many ninths? 4 is 36 ninths. So when I look at this, 100 minus 36 gives me what? I get 64 ninths. Extract the square root. Again, we only need to deal with the positive root. Square root of 64 is 8. Square root of 9 is 3. So I get a final length here of 8 thirds. If this length is 8 thirds, what does that mean this corresponding part in a triangle that's twice the size is going to be? 8 thirds times 2, or 16 thirds. And so the whole thing, when you add it together, 16 thirds plus 8 thirds is going to give you the length of that common internal tangent. And so when you combine those, 24 thirds reduces to 8. Now let me show you an alternate method for solving this problem. Kind of like what we did with the other problem. We boxed off one of the sides, right? Well, what if we do the same thing here? What if we extended this side? And what if we boxed it off with the radius here? You see what I did in that kind of quick formation? So I still have my rectangle. Again, this is still a rectangle here. And so what is this added length going to be? 2. And now, does you see how that's an easier way to solve than the similar triangles? Because now, if I want to find my common internal tangent, which I'll call x, all I have to do is use this large right triangle here to here and here. And I don't even have to set up ratios or anything, right? I have x squared plus 4 plus 2 gives me a total length of 6 squared. And that's equal to this, the hypotenuse 10 squared. And so what's going to happen right here? Do I even need to do Pythagorean Theorem? I have 6, 10. This is 2 times 3, 2 times 5. So I have a common multiplier of 2, a 3 blank 5 triangle. So this will be 4 times my multiplier 2. 2 times 4 is 8. Okay. So again, you have those different possibilities. to solve that particular problem.